I'm Yukito no Naka. Sorry. Hello, I'm Yukito no Naka. Today, I will be presenting under the title Insight from the LLM20 question competition. First, I would like to start with acknowledgement and requests. I'm sorry for asking you to send the a question in advance. I truly appreciate it. I'll do my best, but communicating in English is beyond my ability. I apologize, but it would be helpful if you could write down any question other than those sent via email in the chat. Other questions and communication take time to translate, so they take a while. I sincerely apologize. Now, let's start with the agenda. The presentation consists of four elements. First, I will briefly introduce my background. Then, I will discuss the nature of this competition and the key factor for winning based on my personal perspective. Building on that, I will explain the strategy for the answer and the guesser. Now, let's start with the background. My name is Yukito Nonaka. I am currently first year master's student at Aoyama Gakuin University in Japan. I belong to physics laboratory and usually conduct research applying deep learning to physics phenomena. For example, I work on reconstructing material structures from conductance calculation or determining energy from Fourier transformed measurement data. I have also developed a personal application using retrieval augmented generation (RAG) to make reading experimental equipment document less cumbersome. Now, let's start with the nature of this competition. I will start with conclusion. First, it's important to understand that this competition is collaborative. Second, using a well-known method. Third, what is needed in the answer is not correctness, but being common. The submission for this competition involved an agent equipped with both the guesser role and the answer role. The evaluation conducted in a game format. Two people from a team with one person acting as a guesser and the other answer, working together to guess the secret keyword. The different from a typical competition in that in regular competition, everything is done individually and outsmarting others is crucial. As a result, unconventional and previously untested approaches often end up being highly regarded. However, in this competition, cooperation between agents was necessary. So, to win, it was important to accommodate various common approaches and use familiar standard methods. In other words, the most popular offline policy questionnaire agent should definitely be considered. The offline policy questionnaire agent creates a dictionary of keyword question pairs in advance. This approach, which involves making a guess using dictionary, is the essence of the offline policy questionnaire agent. And fundamentally, it doesn't require an LLM. Now, let's say I am the answer, and the secret keyword is the keyword tool. In this case, my role is not to provide the correct answer to the question, but to respond the same way as in this entry. Correctness or incorrectness does not matter. Being the same is what's important. In most cases, grammar is used for preparation. Therefore, what is required from the answer is to respond using grammar. Providing a correct answer is not what's important. Now, let's start with the answer strategy. I will start with the conclusion. First, correct answer are not necessary. What, what is needed to provide answers that fit the offline policy question agent? Second, for questions that inquire about the character structure of the keyword, respond using regular expression. The offline policy question agent generates the question keyword list using Llama. Therefore, I also used Llama 3.1 for my answers. Additionally, for questions that inquire about the textual structure of the keyword, I handle them using regular expression. For example, these questions are related to the attribute aspect of the keyword, so they are generated using Llama 3.1, whereas those questions related to the textual structure, the keyword are answered using regular expression. Now, let's start with the guess strategy. I will start with the conclusion first. It's not so easy to create questions that can divide the keyword space into two parts. Second, however, it's easily achievable by using questions related to the character structure. Third, main guesser strategy following the agent alpha approach. Fourth, replacing the secret keyword occurrence probability with the word frequency as a proxy. In the case of the data exploration, binary search is effective in many cases. So I consider using binary search to explore the object space to find the secret object. Here, object consists of names and attributes. It is difficult to find questions about attributes that can split the object space in half. However, it is easy to find the questions about the name that can split object the space in half. I'll go with this one. Since this game requires cooperation, it is important to ask questions that the answer can understand. Therefore, the most reliable approach is to use questions that the answer has hard-coded with regular expression. The method that meets this condition is agent alpha. This approach prepares a keyword list in advance and performs a binary search in alphabetical order through question. The question used by agent alpha are hard-coded not only in agent alpha, but also in the offline policy questioner agent. Therefore, this will be one primary use. Here are two popular notebooks and the leaderboard analysis notebooks. Basically, I used the agent alpha strategy. However, toward the end, instead of the alphabetical binary search, I switch to the set of standard questions and change the operation to a binary search based on word frequency. Here it is. The left side shows the early to mid stage guesser strategy. It involved sorting the keyword list in alphabetical order and asking whether the keyword comes before, after the middle word in dictionary order, performing a binary search. The right side shows the endgame guesser strategy. In this phase, the keyword list is sorted by word frequency, and binary search is conducted in similar manner to Agent Alpha. This method enables a more meaningful binary search implementation. Thank you for your attention.